now that we have some intuition for how hypothesis tests works and we know some basics of it, we're going to put it all into action and run a hypothesis test. Now, this page is a reference page that we're going to use a lot. It's also available in the exam notes packet. It shows us the technology we need, the requirements needed to run this test for a single proportion, which is the first of many tests we're going to learn. Then left-tailed, two-tailed, right-tailed, which we've already learned how to make hypotheses, right? How to make, how to state what the alpha is, the type 1 error, our test statistic, our pictures, and so on. And then at the end, we'll write our conclusion, which we already learned how to do in section 10.1. Okay, so in a study from 2015, the Pew Research Center found that 24% of adult Americans pay for almost all their weekly purchases with cash, which is true. A credit union researcher believes the percentage has decreased since then. They conduct a poll of 1,068 random adult Americans and find that 18% of them make almost all their weekly purchases with cash. This is real data, in case you're interested. All right. First off, we're going to start off with a review question, which is why the study must have been an observational study and not an experiment. I think must maybe is a strong word. We could have forced people to use cash or credit cards in this case, but it would have been very difficult to do. So very difficult to force people to use cash versus cards. I mean, not everybody has a credit card, and it just would have gotten tricky. So there we have it. I mean, a lot of people that tend to use cash, not all people, but a lot of them tend to not have access to cards. That's one of the reasons they use cash. So, or they might not want to, but that's a whole different decision. Okay, so it would have been just very tricky. All right, now we're going to kind of do this a little out of order. We're actually going to find out our hypotheses first, which if you look at the hypothesis test is actually step 1 of the hypothesis test. So we're kind of doing this bit first. We're going to figure out our null and alternative hypotheses. Now, for one thing, how do I know this is proportions? Well, I mean, I know it's going to be H0 and H1, but I know this is going to be proportion 1. Now, how do I know that? Well, for one thing, that's the section I'm in. But for another, when I look at this, it's talking about percentage right here. It's talking about percentage right there. Percentage right there. There's proportions all over this. It's talking about a poll or a research, right? A survey. So when it talks about polling and surveys, so we'll just make a little note up here. Here, I'll do it in light blue. So note, right? Polls and percentages, surveys, percents mean that P is the parameter. That will be what we're working with in our H0. Just something to note, because we're going to learn several hypothesis tests, so this is going to be kind of a cue for how you're going to know which one you're doing. So this is definitely talking about surveying and polling, therefore it's P. All right, now I assume P equals. Now here's where students get a little confused. What you want to do is look for the past. The past value will be assumed to be true unless we can prove it incorrect with new data. So from the past, we have right here, right? So this is from the past, from an old survey in 2015. So we're going to assume that it's 0.24 unless we can prove it otherwise. And whatever value you have in the null will be the same as the value in the alternative. The difference in the alternative is that it won't be an equal sign, it'll be a direction. So now we have to look for a word that will cue what direction we're going. And the direction is right here from the word decreased. So that means we know we're going less than. All right, so step 1 is done. I've got my hypotheses. Lovely. All right, now they actually want me to backpedal and find my requirements. And the reason I have us do the null and alternative first is because we need P0 from the null, the 0 hypothesis, in order to do the normal bit. So that's why I have us finding the null and alternative first. It's a hint, by the way. If you're finding your null and alternative hypotheses first before you're verifying requirements, that's kind of a cue that you're in a proportion problem. Just a little side note. All right, so let's verify requirements. And we've seen these before. Random, independent of the population, and normal. technically this is of population. Okay. Random is easy because random is almost always given in the problem. And I gave it again. It's right here. When I wrote the word random right there, I'm giving it to you. Done. All right, so that's simple enough. Independent of the population. Well, this should all sound familiar because we've done this. This was from chapter 8, and we did it in chapter 9 as well. It's that sample size has to be less than 0.05 of your population size. So we're going to start with that. So little n has to be less than 0.05 capital N. Little n is our sample size, which is right here. Right? So 1068 is how many people we polled, and that's less than 0.05 of, now capital N is our population size, which is 210 million. So 210 million. Sorry, that was a mistaken pen draw there. I wasn't trying to do anything with that. There we go. Now, sometimes you can bother to find this number. I mean, you could go find it in Desmos if you really wanted to. It's like 10.5 million. But this is so big that we don't have to bother. We know that whatever this number is, it's way bigger than 1068. So we'll just say yes, of course, and call it a day. Again, if you really want to, I mean, I could do it now. It's not particularly difficult. You just have to remember how many zeros are on 210 million. So you go, 0.05 times 210. There you go. 10.5 million. There you have it. So if you want to find it, you can. But with a number this big, it's not worth your time. All right. So this is yes. We've gotten that one. So now let's get normal. Normal is n times p0 times q0 has to be greater than 10. Right? So the question always comes up, what is P0? Why is it saying that? Well, P0 is from the zero hypothesis. It's whatever value we assume to be true. And also remember that Q and P are complements of each other. They add up to 1. So N is 1068 times P0 is 0.24. And Q0 is 0.76. I can just make a little note over here on the side for you. So remember, Q0 is 1 minus P0. So it's 1 minus 0.24, which is 0.76. So 0.76 goes right there. And then we'll just go grab Desmos. Right, that one we will calculate. It's not particularly difficult. Okay, so 1068 times 0.24 times 0.76 is 194.8. And 194.8, last time I looked, is bigger than 10. So yay, we have verified our conditions.